and the approach of the benzaldehyde or the aldehyde is coming in front. If I check which phase is the right one, that has to be the one that I show here, this is the right transition state. Okay? Check it at home that this phase is exactly this phase there. Okay? Then the only that I need to do is to transform this in a zigzag. I can start from here. Okay? Okay, the wedge will be inside. Okay, here I don't have anything, and here I will have the final product. This will be the final product. Okay? How I did it, I checked in which phase will be favored the attack of the nucleophile to the aldehyde, and then I draw both transition states, the chair transition states, and the one that is the attack takes place by the phase that I chose before will be the one that will be favored. Okay? Good. Then we go for the next one. This time we are using we're using this Evans auxiliary, and we react with we are forming the okay. Well, first of all, we are forming the enolate. Okay, the enolate will be this. I remove this proton, and this will be the enolate. Okay. Remember that because we are using oxazolidinone, the enolate is always cis. Okay, to avoid the interaction between the crans and the substituent of oxazolidinone. And this will react with the aldehyde following the typical chair transition state. So you know, both possible transition states. Here I put the boron. Remember, here I put the substituent that I will say this is R. Okay. And then I draw the oxazolidinone. Okay, and remember that because I want to minimize the dipolar moment, the oxazolidinone is opposite, where is the carbonyl of the oxazolidinone is opposite to the carbonyl of the enolate. Okay, if I put it like this, that means that the effect is here, and then I draw the aldehyde, big substituent in the equatorial position, and this will be the transition state. If I draw the other transition state, okay, boron, I do the same. Okay, I put here doxazolidine. Again, I have to put doxazolidine opposite to the carbonyl group, the carbon of doxazolidine opposite, in order to minimize the dipolar moment. Then if I do this, this has to be like this, and then I go aldehyde, putting the big substituent in the equatorial position, and I get these two transition states. As I always draw the enolate in the plane of the slide and the aldehyde is approaching from in front, clearly here the group of doxazolidine is blocking the face behind the slide. However, here this group is crashing with the aldehyde. That means that this will be disfavored. That means the favored one will be this one. I draw it. Okay, if this is the favored one, this is okay, and then this will be inside. Substituent, and here will be doxazolidine. That must be in this stage. Okay? If I didn't do anything wrong, this is the final configuration of the product. I did something wrong. Sorry. This R is not in equatorial, it's in axial. Okay, because remember that it's not grams, it's cis. Sorry for this mistake. Okay, that didn't affect anything. Okay, but then obviously this translates. This translation has to be okay. Has to be like this. Sorry for the mistake, but this is not affecting the approach of the benzaldehyde. Okay? Right? Remember, don't do my mistakes. Check that the enolate is in the right position. That means if this is a cis enolate, this has to be down, okay? And that's all. Thank you very much for your attention.